In this lab, we learn about SSL and the public key infrastructure. So, firstly, we work with OpenSSL, which is a library which implements SSL and and other public key infrastructure protocols. So, firstly, we need to create a root CA. A root certificate authority is one which whose certificate is self-signed, and the root CA then issues certificates to uh, other other clients. So, basically, to set up the root CA, firstly we need to generate its private and public key. We can do that using the request command of OpenSSL, as you can see on the screen. We give the file name in which the private key is output, which is ca.key, and the certificate is output in ca.crt. So now once you do that, you can see, if you enter this command, it will prompt you for uh, other fields which are required to generate the certificate, such as organization name, the common name, the country, and other information. So once you do that, you can see it will generate ca.key, which is the private key, and ca.cert, which is the certificate. Uh, Also, OpenSSL has a configuration file in which you can manage multiple configuration options, such as the directories in which certificates are stored, and the policies and other stuff. But getting back, so now once you've generated the private and the public key for the root CA, uh, you you are done with the setup of the root CA. So this command also signs the certificate of the root CA with its own public key, with its own private key, and so now any client can issue a certificate request to this CA. So in order for client to issue a request, firstly the client needs to generate its private and public key, because it cannot share its private key with anyone else, so it needs to generate its own private and public key. We can do that using this command, which you can see on the screen. It uses RSA to generate the private key, which is 1024 bits, generates the key in server.key. Now after generating the private key, you need to generate a CSR, which is a certificate signing request. So the certificate, once you issue this command, it will ask you for information such as organization name, the common name, which is the domain name of the client, to which for which it requires the certificate, and so on. It will ask, it will prompt you for all those fields which you need to enter. Secondly, it uses the private key to generate the public key, and it also includes that public key in the CSR. So once you issue this command, it will generate the CSR file, which you need to send to the CA for signing. So once you send the file to the CA will verify if the client is genuine, and if it fails, then it'll proceed with signing, creating a certificate for the client. So to create the certificate for the client, uh, we can use the CA OpenSSL CA command. In that, it'll take the CSR file as input, and it'll generate the certificate, uh, and it'll sign it with its private key. So You can see once you enter this, it'll generate the server certificate, which we can see here, and you can see it's issued by CSE 598, which was the root CA. So now we are done with uh, generating a certificate for the client. So we can test this now by accessing the client, the domain name of the certificate, which was CSE598 server.com. So the certificate was generated for this domain. So we can test this by uh, firstly, we can test this. So firstly, we need to start a server which will listen to HTTPS requests for this domain. So we do that by using OpenSSL server s underscore server command, and to that we give an input server.pem, which is a file which contains the both the private as well as the certificate of the client, and basically it'll use so whenever it receives requests, uh, uh, it'll in response it'll send the certificate, and also while uh, so you need yeah so basically you need to start the server. So once you do that, uh, it'll ask you the passphrase for the private key, and once you do that, the server is running now, so it'll this listens to requests on port 4433 by default. So now if you try and access the CSE598 server.com via HTTPS, and it'll display this web page, and you can see this certificate which is issued by the root CA. And this is possible because firstly I had added the certificate to the certificate authorities list in the browser, had imported the root CS certificate, which you can see here. uh, here. So now this is added in the certificate authorities, so all certificates issued by this CA will be trusted. And so that's basically uh, about certificates and HTTPS and SSL. Thank you.